The middle of September is the peak of hurricane season in the North Atlantic. In the modern era, it's safe to assume that ships have almost as much access to modern weather forecasts as you do on your television or computer. But as evidenced by the loss of the Bounty in 2012 and the El Faro in 2015, sometimes that isn't enough to keep ships safe at sea, and before modern satellite weather, ships had to be even more self-reliant. The first basic principle of navigating around hurricanes is to not be anywhere near a hurricane during hurricane season. Often the easiest decision is to simply route yourself outside the danger zone. Hurricane season in the Atlantic Ocean runs from June 1st to November 30th, but the peak of the season is clearly August, September, and October. Historical hurricane tracks show that most of the impacts are in the northern Caribbean Sea and western Atlantic. However, historical tracks show that almost any part of the tropics or mid-latitude Atlantic Ocean can see the effects of a hurricane. Insurance providers often require smaller vessels to be south of 10 degrees north latitude or north of 30 degrees north latitude during the peak of the hurricane season as a precaution. Not all ships can simply avoid the entire western Atlantic during hurricane season. Another strategy is to carry on with typical operations, but to use the ship's propulsion to avoid the storm's path once it has been forecast. To this end, vessels and shore coordinators exchange information about the location and forecast path of a hurricane, and the vessel master navigates to avoid the storm, hopefully by a large margin. Take a look at the location of this hurricane compared to the AIS reports for vessel locations in the western Atlantic at the same time. Just like if you lived on the coast in the path of a hurricane, there's often enough time to avoid the worst effects by evacuating the area in the path of the storm. But sometimes a vessel finds itself uncomfortably close to a hurricane. How would a vessel navigate within the wind field of a hurricane? Well, because the storm is cyclonic in nature, but is also generally moving in some direction, there's definitely a preferred side to pass a hurricane on. The side in which the storm's momentum adds to the storm's wind speed is called the dangerous semicircle, and that should be avoided. The side in which the storm's momentum is subtracted from the storm's wind speed is called the navigable semicircle, and it's marginally safer, but not always. One factor to consider is the effect of wind speed against ocean current. Winds generate waves on the ocean based on three factors: speed, duration, and fetch, or the distance that the wind blows over. But local effects can increase or decrease the size of these waves. For example, the oceanic current called the Gulf Stream moves northeast along the east coast of the USA. Sometimes it moves at speeds over 2 knots. When a wind blows directly opposite the Gulf Stream, it can cause the waves to become exceptionally steep. This is one contributing factor to the loss of the HMS Bounty replica in 2012. She was in the navigable semicircle of Hurricane Sandy, but the combination of northerly winds and the Gulf Stream made for an extremely large sea, which eventually overwhelmed the ship's ability to stay afloat. Other times, vessels may find themselves close to a storm but cut off from modern information about the storm, and this can be a truly scary situation. A key principle is that generally the worst weather happens closest to the center of the storm. One way to find where your ship is in relation to the center of the hurricane, or any low-pressure system, is called Buys-Ballot's Law, named after a Dutch meteorologist. The law states that if you're in the northern hemisphere and you put your back to the true wind, the center of the low pressure system is generally to your left and slightly forward. As a general rule, this serves masters well, because they can take action to avoid the worst part of the storm, the center. Similarly, if one finds themselves near the center of a hurricane, the ship radar S-band, or long-range mode, can help deduce the rotation and location of the center of the hurricane, thereby helping the master take avoiding action from the worst seas. Another general navigation rule for masters based on the principle of navigable and dangerous semicircles is illustrated in Weather for the Mariner by Admiral Koch. It states that if you find yourself in the navigable semicircle and don't have any other information, you should put the wind on your starboard quarter and make as much speed as possible. If you're in the dangerous semicircle and don't have any other information, you should put the wind on your starboard bow and make as much speed as possible. Finally, if you're in the direct storm track, you should bring the wind 2 points on the starboard quarter, about 160 degrees relative, and make as much speed as possible until clear of the eye. These rules will help you avoid the center of the storm and the worst effects. Finally, the U.S. Coast Guard believes that vessel masters should retain a thorough understanding of the relative motion of hurricanes and how to take avoiding action to keep the maximum distance from the center of these storms. Vessel masters use a maneuvering board, which is a tool for vector addition to help them find the optimal path away from a hurricane. Here's an example problem from the Unlimited Master Test in the Navigation General module. To solve this problem, we assume that the ship is located in the center of the maneuvering board, and the course that we're on, 050, doesn't really matter. We're going to plot the position of the hurricane at 100 degrees true at a range of 90 miles with the symbol C. The next step is to plot out the true motion of the hurricane, however we get that information, whether it's from a weather forecast, somebody ashore, or other means. In this case, the storm is moving 285 degrees true at 19 knots. So we'll use a 2-to-1 scale to plot the motion of this storm. We'll label that point A. This represents the true motion of the storm. But don't forget that our ship is also moving. And in the problem, it states that we're going to move 10 knots. So again, using the 2-to-1 scale, I'm just going to mark out the 10-knot circle, which is equivalent to the 5-knot 1-to-1 circle. Based on this arc, if I move from point alpha to a point tangent to this 10-knot circle, I'll have the desired course to steer to maintain the maximum CPA, or closest point of approach to the storm. In this case, it works out to be 227 degrees true. What I've done in this problem is to solve for a case in which I can move 10 knots and the storm is moving 19 knots, how to maximize my distance from that storm center. So if I point my ship at 227 and go 10 knots, I'm going to be as far away from that storm as possible. It's not necessary to solve in this problem, but the vector BA is also the relative motion of the hurricane's center from us if we're moving on a course of 227 degrees true. So if you needed to calculate the distance at which that storm is going to pass you, you can use this method as well. In conclusion, if you can't avoid a hurricane, the best way to navigate around it is to use tools such as weather forecasts, radar, anecdotal rules, and the maneuvering board to keep yourself as far from the center of the storm as possible. Always remember that the destructive power of hurricanes extends far away from the eye of the storm, and the best thing you can do is maximize your distance from it.